Hello everyone, hope you guys are doing good. So today we are going to cover a problem related to binary trees and recursion. So problem name is find leaves of a binary tree. So here we are given the root of a binary tree. Collect a tree nodes as if you were doing this. So like we have to collect all the leaf nodes and we have to remove those leaf nodes and we have to repeat this process until the tree is empty. So in this problem 1, 2, 3, 4 and 5, the leaf nodes initially are 4, 5 and 3. So we take those leaf nodes into the output vector. We remove those leaf nodes. So after that the tree would be just 1 and 2. So we remove 2 after that because 2 is a leaf node over here and put that inside another array. So we remove 2 and after that we are just left with node 1. So we remove that one as well. So we insert that in another array. So finally we have to return an array of array or a vector of vector in C++ based on these conditions, right? So the question is very simple. So let's see with the help of an example. So I will draw one tree over here. So the tree can be 1, 2, 3, 4, 5, 6, 7 and let's suppose 8 over here as well. So what is the output over here? So initially what are the leaf nodes possible? 4 is a leaf node, 8 is a leaf node, 6, 7. So 4, 8, 6 and 7. This is one vector. So we have to remove those. After that the tree would be 1, 2, 3 and just 5. Right, what are the leaf nodes over here? 5 and 3 are the leaf nodes. So 5 and 3 in another vector. We remove those again. We are left with just 1 and 2. Here just 2 is a leaf node. So we keep it inside another vector. We remove it as well. So we are left with just 1. So this is also a leaf node. Right, so we have to return this array of array as the final output. So what is the approach that we can use over here? So it looks like in binary trees we usually use recursion. So here like we have to do a bit of modified version of recursion. So because like we won't be processing a particular element when we are at that particular element. So like if we do a just pre-order traversal or in-order traversal for that matter, right? If I am at a particular node, so suppose I am at 2 and these two left and right childs are yet to be processed, like I haven't gone through the left and right subtrees yet. So in those cases like I won't be knowing what is the current level of this level 2 node 2, right? So if we are given a tree, let's draw it. So if I am at this particular level, this particular node, right? So when will this node be inserted inside this output vector, right? So for that to be sure, I firstly need to process whatever is present in its left and right subtrees, because we have to take the leaf nodes first and then we will be slightly going up one by one, correct? So suppose this node has a left subtree as well and the right subtree as well, and the height of its left subtree is suppose 2 and the height of its right subtree is suppose 3, right? So we can be very much sure that this node won't be printed before all its subchilds are printed, because this node will be converted into a leaf node only when the left nodes for this particular node and the right nodes for this node are already removed, right? So for the left tree to be completely removed and the right tree to be completely removed, like what is the basically the step number at which this node will be converted into a leaf node? So that will be actually step number basically 3 plus 1. So whatever the maximum of these values is, 2 plus 2 and 3, we take the maximum of that and we increment 1 to it, because the right subtree, suppose this is the right subtree, so it has 3 nodes with it. So at the first step this node will be deleted, at the second step this node will be deleted, at the third step this node will be deleted, right? At the fourth step we will be coming up with this particular node, and at fourth step this node will be converted to a leaf node. right? So what we understood from this is that for a node to be converted into a leaf node, all its left and right subtrees has to be first processed, and then only we will be going through that particular node, right? So here the concept of backtracking comes into picture. So if I write a normal function, right, in which I'm going to pass root node and one variable, let's call it level, right? So level over here denotes like what is the level of that particular node from the leaf node, starting from the leaf node. So here the level of this particular node would be nothing but the maximum value of its left and right trees levels, which is 3. The maximum value is 3 and incremented by 1. So the level for this particular node is 4. Similarly, the level for if we go via this example, so what is the level of the leaf nodes? So the level of leaf nodes would be nothing but 1. Similarly, this would also have a level of 1, 6 would have a level of 1, 7 would have level of 1, right? So to find the level of, suppose this 5, right? So 5 doesn't have left child, so 0 will be returned from over here, and 8 already has a level of 1. So what I told you that like we would be taking the maximum value of the levels returned from the left and right subtrees, which is nothing but 0 and 1. So maximum value of 0 and 1 is 1, and we will increment 1 to it. So the level of 5 would be 2. So I will write the basic code over here, and then we will jump over to the coding part. So if the root is null, then I'm going to return 0. I'm going to return 0 over here, right? And then I'm going to recursively call the left trees, and similarly the right trees as well, correct? So once the left and right subtrees have been properly gone through, so we would be basically doing in the backtracking step, we would be already knowing what is the level of that particular node. So this suppose the left subtree level is A and the right subtree level is B. So for the current node which I am at, the root node which I am currently at, so what I have to do over here is, let's create one variable called x, and I am going to take the maximum value of A and B. So whatever the maximum value of A and B is, I just need to so as you can see over here, we have to return a vector, right? So the maximum value of A and B is going to denote the index in which we are going to insert this vector. So suppose the maximum value of A and B over here comes out to be 0. So because this is a leaf node, right? So these will be returning 0 to it because root is null. So these imaginary nodes would be returning 0 to this 4. So x value is nothing but 0 over here. Maximum of 0 and 0 is 0. So in the answer vector that we are going to return, so in the 0th index I am going to insert this x value. So I am going to push this x over here, not x, sorry, the root value, right? And finally I am going to return x plus 1 to the parent node, right? So I will write the code for this now, if the logic is clear. So we will see if some things are pending to explain. I will explain in between. So vector of int we have to finally return. So let's call it answer, and I will create one function called let's call it func only as of now. We can rename it based on its function, and I have to pass one variable which is going to tell me the level of that particular node from the leaf node. So we will be initializing it to 0, and I'm writing this function which is returning int tree node star root and int level. So one termination condition we can write over here is, if root is null, we have to return 0. right? So that's what we were doing over here. Like it is a leaf node, root node, sorry, it is a null node, so we are returning 0. We are returning 0, and we can create two variables, int a equal to get the basically the level of the left subtree, function of root left level, and b variable is used to get the level of the right subtree. So whatever the value a and b I have received with me, so for the current node, which is nothing for the root node, so in this recursion call I have to take a decision. Let's call variable x as max of a and b, right? So over here I've created one answer vector that we have to return. So x is nothing but the index of the answer vector in which I am going to insert this root value. So answer of this x is nothing but the index in which I am going to insert it. Push back root value, because as you can see over here, like this is what I have to return. So this is index 0, this is index 1, 2 and 3. So firstly I will be encountered with 4, 8, 6 and 7, right? So so x value is initially 0, as I mentioned over here, x value is 0. So at the 0th index I am going to insert this 4, right? When I had reached suppose this 5, right? So here I would be getting a as, suppose I am in this node 5, so a value I will be receiving as 0 from this imaginary null node, and b value I will be receiving as 1. So I will be taking the maximum of a and b, which is 1, and I will be inserting this 5 at the first index, this x value will be maximum of these two, which is nothing but 1, and I will be inserting this 5 node 5 value into the first index over here. So that's what I am doing here. Answer dot pushback, and finally I have to return x plus 1 to my parent node. I guess this should be fine. Let me try to run it. Known void. Okay, I have to return answer. Okay. Yeah, I guess the problem is that we are pushing back the elements into the answer vector, but we haven't created that particular index. So let me just write an if condition over here. If answer dot size, or I can say if x is greater than equal to answer dot size, which will be 0 initially. So over here I can create one empty vector, and yeah, so I'm initializing basically this answer vector with an empty, because it's a vector of vector, array of array, kind of matrix thing. So I have to create that 1D matrix, 1D array, and insert into that 2D array, right? Let me try to rerun it. Yeah, this looks fine. If I submit it, yeah, runtime, memory usage are perfectly fine. So over here, like we have completed, like basically understood the concept of backtracking along with recursion. So in recursion, basically what we usually do is we keep on going down in the trees, and simultaneously we process that particular node as well. So if we would have been processing the root node over here, right, so then we would have called it as a recursion problem. But like here as well, it is recursion, but we are doing the processing stuff once we have completed the processing of its left and right subtrees, right? So here we are doing the processing part. So here this is the backtracking step. So basically we are going from bottom to top of the tree once we have completed all the nodes visiting part, right? So I hope the solution is clear. So if we discuss about the time complexity for this approach, like as we can see, we are processing or visiting a particular node I guess 2 times. Like once we are going through top to bottom in the recursion part, and when we are backtracking as well, we are visiting that node again, right? So here we are visiting one node 2 times. So if there are n nodes, then 2n is the time complexity, which is nothing but O of n only, and space complexity is also O of n, the recursion stack that we are using. If that is not counted, then we can call it as O1 as well, right? So time wise and space wise, the solution approach is also fine, right? So I will paste this solution in the comment section as an ID1 link, so you can refer to this solution as well. And I hope the solution is clear. So if you have any questions, please do comment, and if you haven't subscribed to the channel, please do. And I will see you next time. Thank you.